Hi, I'm Kenny Green.
I'm Remington Myers,
And I'm Andrew Vidrine.
and this is our project on additive manufacturing. What is additive manufacturing? Well, it is also known as 3D printing, and it is a technology that creates objects by adding layer upon layer of a chosen material to allow drawings or animations to come to life.
So there are several different ways to 3D print, but the ones we will be discussing today are the fused deposition modeling, or FDM, the stereolithography, which is SLA, or selective laser sintering, which is SLS.
FDM printers come in two main flavors. There's Cartesian and there are Delta. Cartesian printers work in the typical XYZ coordinate system, where the print bed typically moves in one of those directions while the print head moves in two. The picture in the center shows a printer where the print bed moves solely in the Z direction while the print head moves in the X and Y, while the two on the right hand side show different types of printers that can move the print head in the Z and X direction while the print bed moves in the Y direction. The second most common type of FDM printer is known as the Delta printer. These work in the standard XYZ coordinate system also, but the way they get around is a little different. They work by raising and lowering three set points that all converge in a center location. The center location holds a nozzle, and based on which of the 3 points is raised and lowered determines the location of the center, the height of the center, and the direction that the center is going. This creates a cylindrical build volume that tapers off to a point as seen in the picture to the right. They are typically a little bit harder to work with as leveling is a little bit trickier, but they print a little bit faster than standard Cartesian printers. You might be wondering, how do FDM printers work? So FDM printers work by adding layer upon layer using a nozzle that heats up a plastic filament and it deposits layer by layer.
The next printer we're going to be talking about is the SLA, or the stereolithography printer. These machines are all built using a light source, like a laser or a projector, to cure a sensitive liquid, wet resin, into hardened plastic. SLA parts have the highest resolution and accuracy, the sharpest details, and the smoothest surface finishes of all the 3D printers, but it does take longer to print. And also, SLA is also very versatile.
So SLS uses a laser to harden and bond small grains of nylon and sometimes metal materials into layers in a 3D structure. The laser traces the pattern of each cross-section of the 3D design into a bed of powder, which you can see in the picture on the right. The platform lowers and the shape is made just for that layer, and then it lowers again. So after one layer is built, the bed lowers and another layer is built on top of the existing. The bed continues to lower until each layer is built and the part is complete. So we have several different types of materials. For FDM, our more common materials are ABS plastics, PLA plastics, nylon, and polycarbonate. The SLA has, usually we use epoxy resins, and for SLS we use silver, titanium, or steel. The top picture and the picture on the left are filaments, where the bottom right picture is an epoxy resin.
Alright, so there are some industrial uses for 3D printing. The first thing I wanted to talk about was the custom parts. So personally, or from personal experience, I know Lockheed Martin uses a lot of 3D printing for their assembly lines and trying to get through some of the assembling of their missiles and such. So I would assume a couple of other companies use 3D printing as well. And then also, in the picture on the right for the top part, is a large 3D printer, or FDM Cartesian printer, and that large industrial printer created that concrete house on the bottom picture. So it also can 3D print concrete, which I think is pretty neat. And then on the left, the top part is how part is traditionally made. but the bottom part is an example of the unique geometry 3D printers create that are lighter and can also handle load stresses better.
So for prototyping, there's several different things you can do for like automotive prototyping where you have plastics, metals, and rubbers. You can actually, you can 3D print each one of those materials. So you can make an entire car just with one printer. For biomedical prototyping, you can have mechanical pieces that move together. And then you have architectural prototyping where you can just have extremely detailed shapes, and on small scale or large scale.
Let's talk about accessibility. So in years past, it's been really hard to get your hands on a 3D printer, but nowadays there's 3D printers all over campuses. Louisiana Tech has 3D printers down in the basement of Bogard. We have 3D printers in the basement of University Hall in the Thingery, and we also have a few 3D printers in the IFM. There's also a new class that's starting up over at Louisiana Tech, and it's a 3D printer additive manufacturing class where you get to build your own 3D printer and learn about this in more detail. If that doesn't strike your fancy, there's also lower printer costs. So nowadays you can get printers under $200 and rolls of filaments for about $10, $15. If neither of those work for you, there's also online services where you send in whatever part you want and they'll charge you a little bit of money, but you get back a custom one-off piece. This is useful if you don't need a large quantity or if you don't want to spend a lot of money on a 3D printer.
And finally, these are just a few of the references that we use to create or to find out the information for the 3D printers. This is one of our access locations for our 3D printers at Louisiana Tech. Here are some of the 3D printers. This printer right here can print in carbon fiber. Some more. We have a lot of printers if you can't tell. And then these two can print in rubber or flexible items. See? And then some more. And then this one actually has an object in there right now. So yeah, one of our access locations.